This is section 9.5, Effects of Changing Dimensions. The objectives of this lesson is to describe the effect of perimeter and area when one or more dimensions of a figure is changed, and to apply the relationship between perimeter and area in problem solving. We're going to start by looking at the effects of changing one dimension. So in the example of this rectangle, we're either going to change the height or the base, but just one of those. We're going to describe the effect on the area of a rectangle if the height is tripled. So if we're just going to triple the height, so instead of 4, we're going to triple it and we're going to make that 12 feet. But before we do that, let's take a look at what the area is for the original figure. Remember, area is base times height. So that's going to be 7 feet times 4 feet. We have 28 feet squared. Well, let's look at that. If we triple the height, we're going to be multiplying it by 3, so we end up with 12 feet. Okay, so the area would be base times height again. It would be 7 times 12, which is 84 feet squared. So what is the effect that that had on the area? Well, let's look at the new area over the original area. And we get that it is 3 times the original area. So if we want to describe the effect that this tripling the height had on the area of the rectangle, the area is tripled. This is actually easy to see if you just look at the formula and not even really pay attention to the actual lengths that are given. If I take the area formula and I triple the height, so instead of base times height, I have base times 3 times height. Just to simplify that, I have 3 times BH. Well, I know that BH is the original formula for area, so I can see easily that area is going to be tripled if I triple the height. Let's do another example like that. This example says to describe the effect on the area of a parallelogram if the base is multiplied by 1/3. Okay, so here we have a parallelogram. We have a base of 12, a height of 9, and using that to find the area, the original area of the figure, again it's base times height, so we're looking at 12 times 9, which is 108 square meters. Okay, if we're going to multiply the base by 1/3, that's the same as dividing by 3. So instead of 12 meters, I will have 4 meters. So let's look at the area for that figure. Again, it's base times height, so it's going to be 4 meters times 9 meters, which is 36 square meters. Okay, again, we're going to look at the new area compared to the original area. We have 36 over 108. And if I reduce that fraction, I get 1/3. So this tells me that the new area is 1/3 of the original area. So the area is multiplied by 1/3 if the base is multiplied by 1/3. And just one more time, we can see that if you just use the formula itself, base times height, and instead I'm going to use 1/3 base times height. And then just by writing that formula, it's easy for me to see that the original formula is here, base times height, but I have 1/3 times that. So the area will be multiplied by 1/3. Okay, now let's talk about changing the effect of dimensions proportionally. So if that's the case, we're no longer just changing one dimension, we're going to change both dimensions by the same amount. So I want to be able to describe the effect on the perimeter and area of the rectangle if the base and the height are multiplied by 3. So we're going to do both the base and the height. So let's look at the original perimeter. Remember, perimeter of a rectangle is 2 times the base plus 2 times the height. So in this case, I'd have 2 times 8 plus 2 times 3. And I end up with a perimeter of 22 meters. Now let's look at that if we were to multiply the dimensions by 3. So to multiply these dimensions by 3, I'd end up with a height of 24 meters, and I'd end up with a base of 9 meters. So I now have a perimeter of 48 plus 18, and that will give me a perimeter of 66 meters. So with my perimeter change, my new perimeter is 66, my original was 22, so it looks like if I multiply the dimensions by 3, my perimeter is multiplied by 3. So let's take a look at the area. Remember, the area is base times height, so my original area would be 8 times 3, or 24 square meters. Once my dimensions are tripled, 24 meters times 9 meters. And that's 216 square meters. So comparing that with my original of 216 over 24, I realize that my area is multiplied by 9 to get to my new area. So if the original dimensions are multiplied by 3, my perimeter becomes multiplied by 3. But if my original dimensions are multiplied by 3, then my area is multiplied by 9. Or you might want to think of it as 3 squared. This pattern should sound familiar to you. When we're changing the dimensions proportionally, we're actually creating similar figures. When we talked about similar figures back in chapter 7, we talked about whatever the similarity ratio was between the two figures, the perimeter ratio was going to be the same. And the area ratio would be that squared. And that helps us find the perimeter and the area of similar figures. The same is true here. When we affect the change of the dimensions proportionally, whatever that change is, and here we're calling it A, the change of the perimeter or circumference will be by the same amount, but the change in area will be by that change squared. Let's do one more example like that. In this example, we're asked to describe the effect on the perimeter and area of a circle if the radius is multiplied by a half. So let's start with the circumference. And that formula is 2 pi r. So if my radius is 10 inches, that's 2 times pi times 10, or 20 pi inches. Let's look at the circumference if we multiply that radius by a half. So if multiplying the radius by half, it's the same as dividing it by 2, so I end up with 5 inches, which is 10 pi inches. So again, we see if the radius is multiplied by a half, then the circumference ends up being multiplied by a half. Let's look at the area. Area is pi r squared for a circle. So we have pi times 10 squared, which is 100 pi square inches. Once we take half of that radius, or 25 pi square inches. Okay? Notice that that new area is a fourth of what it was originally. So that area is actually multiplied by a half squared, or 1/4. One last thing we're going to talk about is the effects of changing the area. So here we have a square that has a side length of 5. If the area is doubled, what actually happens to the side length? Just recall what we've done in the past. Whatever change we have in the dimensions, we take that and we square it to find the change in area. Well, if we actually have a change in area, we're trying to find the change of dimensions, we're going to do the opposite of that. We're going to take that change and we're going to take the square root of it. So we square the change to find the new area. And we take the square root of the change to find the new dimensions. We're going the other way. So let's look at that in practice. Okay, we have a square with a side length of 5. So let's look at that area. We know that the area of a square is side squared. So if our side length is 5, we end up with an area of 25 square inches. Okay, and then they say, well, the area is going to be doubled. If I doubled that area, it would be 50 square inches. So I'm going to take 50 square inches and figure out what is going to be my new side length. I'm just going to solve this for the side length. To find the side length, I take the square root of both sides, and I end up that square root of 50 is my new side length. If I simplify that radical, remember, 50 is the same as 25 times 2, and the square root of 25 is 5. So I take that out, and I have 5 times the square root of 2 equals the side length. And let's look what happened. We originally had a side length of 5. Now we have the side length of 5 times the square root of 2. So we take the square root of that to figure out what the change is on the side length. So again, looking at my little diagram here, whatever the change is in the dimensions, we square that to find the area. But whatever the change is in the area, we take the square root of that to find the dimensions. In our previous example, we doubled the area. So if we double the area, we're going to take the square root of that to find the dimensions. And that's what we found was true. So here's a couple that I'd like for you to try on your own. I'd like you to pause the video, try them both, and then start the video back up and check your answer. That's all we have for today. If you want some extra practice, please go to your textbook, pages 622 through 526. There's some extra examples and some extra practice problems where you can look and find the answers to the odd numbers in the back of your textbook. And also you can try the online textbook where there's some more videos that you can watch and some additional practice problems. See you tomorrow.